Alright guys, it's going to cover percent composition. You'll really like this. It's pretty simple. You've done it in math without even knowing you've done it before. So let's go ahead and get into it. With any percentage problem, you're always comparing part of something to the whole of something. That shouldn't be any news, but in chemistry we do this based on mass, not the number of atoms. Remember, each of those atoms weighs a different mass. So if we did it by the number of atoms, everything would be thrown off. So we always do it by percent of the mass of the entire compound. So you got steps for finding percent composition. Number one, as usual, write the correct formula. Number two, find the formula or molecular mass of the entire compound. You're going to use that in every step. And then divide the total mass of the element that you're looking for by the total mass of the entire compound. Then number four, since there are no significant figures, round it to 2 decimal places and add the percent sign. So here we go. We're just dealing with percentages again. Let's go ahead and get started with the work. What is the complete percent composition of mass of potassium carbonate? So the first step you got to do is find the formula for potassium carbonate. If you don't know how to go back to do formulas, please go back and review the videos from Unit 6. Oh, I lost my place in my notes. There we go. Okay, so potassium carbonate is K2CO3. If you miss that step, everything else goes wrong. So now, let's start with the first element. We do the percent of potassium. There are 2 potassiums. We're going to do the number 2 times its molar mass of potassium. Go look on the periodic table. It's right here. You'll find that's 39.01. If you take that, make sure you use parentheses, divide it by the whole molar mass of the compound. So we've got to find the molar mass of the compound, which equals 138.21. And that's all you got to do. Do that math, and you get 56.58. The math, that gives you 56.58. 0.5658. Times that by 100, so I forgot that part, and it gives you 56.58% potassium. This looks like a long problem. It's really not that bad. So let's go to the next element, which is going to be percent of carbon. There's 1 carbon atom. The molar mass of carbon is 12.01. So that's your part. Divide it by the whole of the 138.21. That will give you 0.0869. Times that by 100, and that gives you 8.69% carbon. And finally, for oxygen, start over here, percent of oxygen. There are 3 oxygen atoms. Each oxygen atom weighs 16.00 grams per mole. That's your part. Divide it by the whole, 138.21, and that will give you 0.3473. Times that by 100, and you get 34.73% of oxygen. So that's your entire breakdown right there, and that's really as hard as it gets. So we keep on going. And what is the percent of calcium and calcium phosphide? So here we don't have to do the whole thing. We just got to find the calcium. So first step is always find the chemical formula, which is going to be Ca3P2. Then we got to find the molar mass for Ca3P2, which is 182.18 grams in every mole. So now we just need to find the percent of calcium. So percent of calcium. There are 3 calciums. Each calcium has a mass of 40.08. That's your part. Divide it by the whole, which is 182.18. And that will give you 0.66. Times that by 100, you get 66% of calcium. So see, these are easy. You should like these. The next one, percent of oxygen and barium chlorate. So first step, find the formula, BaCl. Whoa. Start that over. BaClO3 2. That that molar mass gives us 304.23 grams per mole. So now we just need the percent of oxygen. So percent of oxygen, remember these are going to multiply. 2 times 3 gives us 6 oxygens. Each oxygen has that very familiar 16.00. There's your part, divided by the whole, which is 304.23. And that will give you 0.6208. Times that by 100, and you get 62.08% oxygen. So there we go. Moving on to the next one. You got 2 ways of doing this. How many grams of pure magnesium could be recovered from the decomposition of magnesium fluoride? So by now you should know there's 2 ways of doing this problem. You can either do method 1, which is dimensional analysis. I'll write that up here. Or is method 2, which is percent comp. Percent comp is easy. I'm not going to do the breakdown dimensional analysis for you because if you're using dimensional analysis, you know how it works. But those are very long problems. You'll find out percent comp is very easy. So I'm going to do step by step with this first one. Is you would start with, hold on. First, you need a starting mass, which is 49.4 grams of magnesium fluoride. So now we can start 49.4 grams of magnesium fluoride, which is MgF2. Molar mass, which is going to be 62.31 grams of magnesium fluoride. And 1 mole of magnesium fluoride. And 1 mole of magnesium fluoride has Avogadro's number of particles, which will be formula units. And then in every 1 particle, there's 1 atom of magnesium. Then in every mole of magnesium, you have that many particles. And then every 1 mole of magnesium has a mass of 24.31 grams. So you see how long that problem is, but if you understand dimensional analysis, you get the same answer as if we did the percent composition, which is easy. We start off with MgF2, which has a molar mass of 62.31. Then you would just do percent magnesium, would be 1 magnesium times its molar mass of 24.31. That's your part, divided by the whole of 62.31, which gives you 0.39. Now here's the only trick now. You've got a starting mass and you've got a percentage. So you have to take a percentage of the starting mass, which means you've got to keep it as a decimal for now. So you take that 0.39, and you multiply it by our starting mass, which is 49.4. So I'm running into here now. And that will give you your final mass, which is 19.27 grams of magnesium. So you see that bottom way, method 2, is substantially easier, shorter, more time consuming than method 1. I'm still going to show you the dimensional analysis for the next problem before we end this video. Alright, so here's the next problem. How many grams of calcium are present in 156.8 grams of chalk, which is calcium carbonate? I went ahead and did the first one out for you. You got to convert it to moles, then to particles, then convert it to atoms of calcium, to moles of calcium, to finally grams of calcium. So I didn't want to take your time up with that. So let's go on to the next one, the percent composition. You have calcium carbonate, which is CaCO3. That has a molar mass of 100.9 grams per mole. So you're trying to find the percent of calcium. So you have 1 calcium atom. Each calcium has 40.08 grams per mole. That's your part, divided by the whole, which is 100.9. That gives you a decimal of 0.397. So there's your percentage. Now you got to multiply it by the original mass. So times that by 156.8 grams, and that will give you 62.28 grams of calcium. So whichever way you want to define that, you can find it. But obviously one is a little bit more quicker than the other. Moving on. How many grams of pure iron can be recovered from 50 grams of a blah, blah, blah. You read that for yourself. All right, I'm not going to do the dimensional analysis for this one. If you want to try the dimensional analysis, feel free to go ahead and do that. But just check, make sure your answer is the same as the percent composition way of doing this. But for this, you've got to first find the mass of iron 3 nitrate in your gram sample. So you got 32% of iron 2 nitrate and 50 grams. So the first thing you got to do is do 50 grams times a decimal percentage, so 0.32, gives you a total of 16 grams of iron 2 nitrate. All right, now that we have our actual mass of iron 2 nitrate, let's go ahead and find the percent comp. So first step is always find the molar mass, so Fe in O3 2 has a molar mass of 179.87. Okay, so now we're going to find out percent iron. So percent of Fe, there's one iron atom. Each iron atom is 55.85 grams per mole. There's your part, divided by the whole, which is 179.87. That will give you a decimal of 0.31. Now you multiply that by our new mass, which is the 16 grams. Just the iron 2 nitrate is all we're concerned about. So multiply that by 16, and you get your 4.96 grams of iron. So if you did the dimensional analysis, make sure you get 4.96 grams of iron. If you get anything else, something has gone wrong. And bring that to me or to your teacher, and we'll figure out where you went wrong. Keep on going. This is a very similar problem, 95% calcium carbonate. How many grams of pure calcium can we get from a 100 kilogram sample? So once again, I'm not going to do dimensional analysis for you, but though it should stick out is kilograms right here in your question, and it's asking for grams, so you've got to convert that, but we'll do that here in a bit. So first, let's find out how much pure calcium carbonate we're dealing with. So you have 0.95% of a 100 kilogram sample, so you multiply those together, and you get 95 kilograms of calcium carbonate. So now remember, you've got to convert kilograms to grams, so there's another dimensional analysis problem here, but this is just a one step. The kilo is bigger. Kilo stands for 1,000, so it's 95 times 1,000 gives us 95,000 grams of calcium nitrate, or calcium carbonate. So now we can do a percent composition. CaCO3 has a molar mass of 100.9 grams every 1 mole. So we're looking for just the calcium, so percent Ca. There's one calcium atom. Each calcium is 40.08. There's your part, divided by the whole of 100.9. That gives you a decimal of 0.397. Times that by our mass, our new mass of 95,000. And that will give you that will give you 37,740 grams of calcium. So if you did the dimensional analysis, make sure you're getting that point. Make sure you realize that you had to convert between kilograms and grams. If you got 37.74 grams, it means you didn't convert. So that's all for this video. We'll see you in class, and we'll do a lot of these problems in class.